Okay, in this video we're going to talk about permutations. So permutations, right, count outcomes used when little n objects are to be selected from a set of big N objects where the order of selection is important. So permutations are very similar to combinations, except permutations, the order does matter. Combinations, it does not matter. So here's the counting rule for permutations, the formula. Let's go through an example and then we'll use the equation, use the formula. So how many different possible outcomes are there if I'm interested in the top 2 sales reps out of 4? So here are 4 sales reps. We have person A, B, C, and D. And we want to know, well, how many different outcomes are there of the top 2 sales reps? So we can start like we have in the past, right? We could get AB, AC, AD. We get to the end of the list, so we start with B, BC, BD, end of the list, so then we go to CD, and we could stop there, but remember, order does matter. So remember, A and B does not equal the same thing as BA. So it's kind of like, what's the difference between AB and BA would be, for our example, person A finished first, followed by person B, but in this situation, person B finished first, and then person A finished second. So, if you have sales reps and you're looking for the top 2, you'd probably want to know, right, that these 2 combinations that we have here are actually different, right? Probably person B would be mad if you said AB is the same thing as BA, right? Because they'd be like, well, no, I'm first. So, think about that. So now we got to go back and consider the fact that AB does not equal BA. So we got to count these as well. BA, we got to go back to C. So we have CB and CA. We got to go back to D. So we have DC, DB, and DA. So if we count all those together, we get 12. So remember, because if we had just stopped here, right, and we didn't think that AB and BA were equal, we'd stop here, and then we'd get 6, right? So that would be 4C2. Right, would be the combination. We get 6 combinations, but that's not the case. So technically, typically permutations, you'll find more different possible outcomes compared to combinations because the order does matter. So let's actually look at our equation. So how many different sets, right, are possible outcomes are there, right, using 4P2, right, because we're looking at permutations, not combinations, right? We have 4, right, when we're selecting 2 little n, if you will, from big N, 4. And here's the equation. It's big N, right, 4 factorial divided by n minus big N minus little n, so it's 4 minus 2, 2 factorial. Remember, the 2 and the 1 cancel out, so it's just 4 times 3 is 12. So that's your answer, 12, and we already counted them up. But again, right, this can be a timely process, especially if you get into bigger numbers. So the formula helps, but again, you can also do this in Excel. For P2, you use the function PERMUT, 4, 2, right, big N followed by little n, and you get 12.